explain the two options given to Farid. Farid wants to buy a boat in 2 years and 4 months, and he currently has 12,500 ringgit in his savings. He is considering two choices. In option A, Farid keeps the 12,500 ringgit in a savings account that gives 6.5% interest, compounded semi-annually. After calculating using the compound interest formula, the mentioned amount becomes 14,512 ringgit and 10 cents. While in option B, Farid takes a 1,500 ringgit personal loan with 4.5% interest, compounded monthly for the same period. Based on the calculation, the total repayment he must make is 16,655 ringgit and 74 cents. When we compare both options, option A is clearly better. So, the most financially beneficial choice for Farid is option A. On to the next question. Rafi is given two options. Option 1 is to wait 3.5 years to receive 50,000 ringgit. Option 2 is to take 44,000 ringgit immediately and invest it in an account that earns 4.8% interest compounded every 4 months. So first, I calculated the interest per compounding period. Since interest is compounded 3 times a year, I divided 4.8% by 3. Then, I used the compound interest formula, where P is 44,000 ringgit, I is the interest per period, and N is the total number of compounding periods for 3.5 years. After calculating, the 44,000 ringgit grows approximately to 52,123 and 47 cents. Because 52,123 and 47 cents ringgit is more than the 50,000 ringgit he would get later, the better choice is for Rafi to take 44,000 ringgit now and invest it.
So here's the question for number 3. Mr. Tan, age 40, begin saving for retirement by investing 120,000 ringgit in retirement fund that pays 5.2% interest compounded quarterly. 5 years later, he received a salary increment and invests an additional 80,000 in the same account. The fund continues to accumulate interest at the same rate until he turns 58. So here's the explanation for question 3. Mr. Tan begins saving for his retirement at age 40 by depositing RM120,000 ringgit into a retirement fund that earns 5.2% interest compounded quarterly. Since he will retire at age 55, this investment grows for 18 years or 72 quarterly period. Using the compound interest formula, the value of this first deposit at age 55 becomes 304,131.44. 5 years after his first investment, when he turns 45, Mr. Tan receives a salary increase and contributes an additional 80,000 ringgit into the same fund. This second deposit grows for 13 years, equivalent for 52 quarterly periods, and accumulate to 156,596.17 ringgit the time he reached 55. However, even though the account grows significantly, the final amount of 460,727.61 still below 500,000 ringgit. Therefore, Mr. Tan will not achieve at least 500,000 ringgit by age 55 based on his current investment plan.
Siti's father left RM2.3 million and it was divided between Siti and her sister Sairah in the ratio 7:3. This means Siti received the larger portion. When we calculate the ratio, Siti's share works out to RM1.61 million and Sairah received the remaining amount. Siti decides to use her entire share as the down payment for a cosmetic factory priced at RM4.2 million. Since her down payment isn't enough to cover the full cost, she takes a loan from the bank to pay the remaining amount. So, the amount she still needs to borrow is RM2.59 million. Now, the bank charged 1.4% interest per year that compounded monthly and the loan will be repaid over 35 years. So, we convert the I is 0.014 over 12 and the total number of monthly payments is 420 months. To find the monthly payment, we use the standard compound annuity formula. So, Siti will need to pay RM7,803.92 every month for 35 years to repay her loan. On this slide, we are calculating the total interest charge on Siti's loan. First, we multiply the monthly repayment by the number of payments. Then, we subtract the original loan amount. After calculating, the total interest charge is 687,646 ringgit and 40 cents. This represents the total interest Siti will pay over the full 35-year loan period. Next, let's look at part C. In this situation, Siti fails to make her first 3 monthly payments. Because she missed these payments, the amounts she owes do not disappear. Instead, each missed payment accumulates interest. To catch up, she needs to settle all outstanding arrears when making her fourth payment. To calculate how much she needs to pay on the fourth month, we use the future value of an ordinary annuity formula because each missed payment grows with interest. Now, we substitute the values. After calculating the expression, this amount represents the total arrears including interest that she has to pay in the fourth month. So, the required payment to settle her outstanding arrears is Rm31,270.35. In this slide, we are finding the settlement amount that Siti must pay after completing 30 years of loan payments. Her loan term is 35 years, so after paying for 30 years, she still has 60 monthly payments remaining. To calculate the present value of these 60 payments, we use the annuity formula shown on the slide. After substituting the values into the formula, we find that the remaining balance Siti needs to pay is Rm451,968.28. So, this is the settlement amount Siti must pay if she chooses to clear the loan immediately after 30 years.
Hi, I'm Nia and I will be doing part B, number 2. Our situation right now is Linino is planning to travel to Cappadocia with his friends and needs at least 45,000 ringgit, but he can only save 550 ringgit per month and is offered 4.2% interest compounded monthly. And we need to find how many monthly deposits Linino must make to accumulate at least 45,000 ringgit. First, we need to identify all of our variables. We need A, R, K, M, and I. Our A will be 45,000 ringgit, our R will be 550 ringgit, our K will be 4.2%, which becomes 0.042, and our M is 12. First things first is finding I, which is K over M, which is 0.042 over 12, and we get 0.0035. Next is identifying what formula we must use. The formula we are going to use is A equals R, 1 plus I to the power of N minus 1 over I. Now we have to substitute all information we have identified to the formula, and it becomes 45,000 equals 550, 1 plus 0.0035 to the power of N minus 1 over 0.0035. Now we have to bring all of our solved variables to the other side, to the left side, and it becomes 1 plus 45,000 times 0.0035 over 550 equals 1 plus 0.0035 to the power of n. Now we solve the formula on our left-hand side, and it becomes 1.2864 equals 1 plus 0.0035 to the power of n. Next, we have to apply the law of log. And our formula will be log 1.2864 equals n log 1.0035. And then n is equals log 1.2864 over log 1.0035, whereas n becomes 72.0734. But fractional months aren't allowed, so we have to round it up, and it becomes 73 months. Bye.